Okay, so short video here, just reflecting over indices questions or log questions. So I'm looking at book 1, Dynamic Maths book 1, looking at page 13, question 66 first. So what we have here is an index question where we have different powers going across, and the problem is this 2 and this -1. And you'll see that it would be impossible to solve this in the traditional index method unless we kind of use some form of substitution. So the first thing I want to do is my 3 to the x is my lowest, let's say, index. So I want to take that 3 to the x and try and find it throughout the rest of the project. Or rest of the question, sorry. And we have 2 3 to the x's here, that's why it's 3 to the 2x, 2 here. So that's what's all that's happened, but everything else is stayed the same. It's at this point now the book uses the letter t, and I'm going to stick with the letter t. I'm going to say that t is 3 to the x, and I'm going to replace 3 to the x in the sum with the letter t. And what you'll start to see forming now is a quadratic. And we can factorize that quadratic. Now, using the guide number method, what we're trying to get here is -2t. So to achieve that then, this would have to be a -3t, this would have to be a plus t. So just to show it longhand, this would be 3t, and then following the red line, this would be t. For me to get a -2t, I would have to have this as minus and this is plus. -3t plus t gives you -2t, which means this needs to be minus, this needs to be a plus. So the factors then are 3t plus 1 by t minus 1, and then solving, we can have 3t plus 1 equals 0, so 3t will equal -1, so t can equal -1 over 3, and on the other side, we can have t minus 1 equals 0, which means t equals 1. Now, what's important here is just to remember that you're not solving for t, you're solving for x. So what we're going to do is we're going to just go back a step and remember that t is 3 to the x. So what we'll have now is that 3 to the x can equal -1 over 3, or 3 to the x can equal 1. Now looking at the top one here, -1 over 3, that's the same as saying -3 to the -1. But it's a very important thing with indices. You can't have a negative power. So this is actually not possible. And in which case we totally ignore it. Now, on the other option, we have 3 to the x equals 1. And if you look at the page 21 of the log tables and look at rule 5, you'll see it says that a to the 0 equals 1. That straight away implies then that for us to achieve a 3 to the x equal 1, it would have to be 3 to the x would equal 3 to the 0. Which means, since both base numbers are the same, the powers can equal each other, which means x equals 0 is the solution to that question. So I would advise you to pause the video, watch this a couple of more times, and if you want to practice more like this, again go to page 66 of the paper or of the book, and if you look at questions 11 all the way up to 15, they practice that. Okay, very common question on the paper. Now we're going to look at this one here, which is a different version of what it says. Some would argue it's much more simpler. The trick here is to spot what's the lowest base number, and in that case 3 is prime, and this is the lowest base number, 3. I want to break up 81 and 27 into the same. So using the calculator, we can get that 81 is 3 to the power 4. 27, so we do 27 equals shift fact is 3 to the power of 3 all over 3 to the power of 5. Now the next objective is, once we have all the base numbers the same, is look at this square root and see is there anything we can do with that. So what we have here then is the cubed root of 27. And even if I was to go back a step, it would be easier for me to actually get the cubed root of 27 now, which is going to give me 3 to the power of 1. You see, both of these are going to end up becoming 3 to the power of 1. Now, don't forget the squared. This power of 2 is going to multiply by this one here, which is again on page 21 of the log tables, and I'm fairly confident, I think it's rule 3, maybe it's rule 7, I don't want to say that, but it's on page 27, that when we have a situation like this, that's the same as saying x to the power of 3 multiplied by 2, which is x to the power of 6. That's the logic I'm applying here. So what that's going to give me then is 3 to the power of 4 by 3 to the power squared over 3 to the power 5. And because these both have the same base number, and have both got the same, have powers, or both have the same base number, we're going to apply rule 1, which is going to give me 3 to the power 6 over 3 to the power 5. And then we can apply rule 2, where we can subtract these powers from each other, leaving us with 3 to the power 1. Now again, you can go to the calculator and you can literally type that in using the fraction button. I will push the fraction button first, e to 1, and then we can do the cube root. It's a bit tricky, but we can do 81 bracket and the cube root, that's 3 there, 27 in there, bracket all to be squared, and divide that by 3 to the power 5, and we get the exact same answer in the calculator. We're getting 3 to 1. Now, but that's not what they're looking for. They're not looking for really for the answer. They're looking for the method, and that goes for the first question also. Okay, so take your time, pause, rewind, watch it a few times, and if you want questions of practice similar to this, page 65, question 2. Okay, thanks.